Hi there. So recently I've been wanting to get into making more and more stuff, and that can involve tiny details in the case of things like electronics when you're trying to solder something like this board I have here, with all sorts of tiny solder joints that you have to contend with. Now, on eBay, I brought myself one of these. This is essentially a digital microscope, and it's, from what I've used it for, well, from how I've tested it, it's working pretty well for me. However, there is one downside. The stand it came with. This is the stand it came with. I'll just move the camera. And the microscope itself would slot in like so, and you would be able to use it like that. Well, that's how it's intended to be used. However, when this would only be really used for stuff like if you just want to view something. However, when you try to do something a little bit dexterous, like say you have a board in front of you and you're trying to desolder some of the components, your dexterity is kind of inhibited. So what I thought I'd do is I thought I'd get a little bit inventive. And so what I've 3D printed is a little piece here which I've sort of reused a microphone mount, and I've 3D printed this this ring piece here. Now, essentially, what it is just this piece that's held to this piece I've reused with a pair of M6, and it has a tightening mechanism here, which is also controlled by another pair of M6. Now, this was just printed in a standard, run-of-the-mill black PLA. However, what's kind of interesting is the type of infill I used. Normally, with a lot of infills, they actually make parts pretty rigid, and so they make them sort of stiff and not very. They don't have a lot of play in them. Whereas this, if I just come here and tighten this M6, don't know if the camera's going to focus. Let's see if I can. Yeah, if I just come in here and tighten this this M6 bolt, you can see that this has enough play to close the gap. Now, the type of infill I've used for this piece is called gyroid infill. Now, essentially what that means is that inside the walls of this object, there is tiny little squiggly lines, like lots of tiny squiggly lines that are in a 3D pattern. And then instead of making this as rigid as if I was to use other infills, this gives it, as I said, a little bit of play. It makes it less rigid. Well, it doesn't make it less rigid, the infill, but it makes it less rigid than the other infills. But the technical term that this mechanism is called is it's called a compliant mechanism. This piece is, instead of being stiff and rigid, it's compliant. I'm just got the wrong piece, the wrong bit there. If I loosen it, and so it sort of goes with the tightening of the bolt. Now let me just attach this quickly, just to show you that it does indeed work. I'll be right back once I've attached it to the this microphone arm that I've bought. So 1 second, I'll be right back. Just as a side note, I designed the bracket in FreeCAD, which is a free design software that you can install on Windows or Linux or whatever platform you fancy, and you can have a fiddle around. But anyway, let's get back to the video. So I have this digital microscope now mounted to the microphone stand using the bracket I 3D printed. It's on, and now I have a lot more dexterity, and I'm capable of a lot more because there isn't any, there isn't any obstructions in the way that could prevent me from doing anything. So, and this just shows how 3D printing can really be used for them really niche solutions, functional solutions that you can't really find a commercial solution for. And that's really pretty much what I wanted to show you today. That 3D printing can be used for many functional things instead of just, knickknacks and such. Anyway, I hope you've enjoyed me showing off this little thing I've made, and I guess I will see you next time. Bye for now.